usually have a mini talk, but since I've been talking a lot over the past few weeks, and last time we only had 2 talks, I do want to get straight into our presenters this week. So first up, we do have Dr. Pooja Sheevam over there. They were inspired by Nova Space documentaries TNG and Voyager, and fueled by astronaut ice cream, not normal ice cream. It was their childhood mission to learn how planets work. However, the quest to study these planets and space objects brought her a little closer to Earth. Following this passion, she is currently starting her career as a researcher at the New Mexico Bureau of Geology after receiving her PhD, congratulations, in geophysics. She's now looking at, or licking, rocks. I didn't have that in, she did, ask her later. She loves digging up information on her latest hobby of catching up with the Crispy Boys Network on Discord. Please join me in a warm welcome for our kickoff speaker tonight, Dr. Pooja Sheevam.
Thank you. It's funny because I didn't even send you that photo, so I'm assuming you got it off my LinkedIn. Or Instagram. But my Instagram's private, so. And I am so sorry. I was told there was no clicker this evening, so I might have to stand awkwardly. My back might be facing someone, so I'm really sorry. But yeah, my name is Pooja. I am actually really excited to be opening up Nerd Night for August for something I'm very passionate about. I promise I made this really fun, not too technical heavy. I won't bore you with rocks. A little bit of... Yes, I'd love to, but I have to change the slides because they forgot a clicker, so I don't have a clicker. Okay. Hold on, I told you I had a clicker. Okay, a little bit, so little housekeeping before I get started. I did invite my work here, so if you guys ever, at the end of this, we do get to the discussion and question portion of the talk. I highly encourage you to come visit this table. We're all geothermal enthusiasts. This is what we live and breathe. And so please, if you have any very specific questions, want to get involved, maybe want to pursue a career in geology, we have some lovely people here to help you out with that. But with that being said, I do see some familiar faces here, which is great. So that means I have friends that support me. But also, what I do professionally, I'm a geologist. I work for the State Geological Survey, and we're called the New Mexico Bureau of Geology and Mineral Resources. We're located in Socorro, New Mexico. We are essentially the science and research arm of the state natural resources pertaining to geology. So that's your hydrology and groundwater, geological hazards like seismic monitoring, earthquakes, volcanoes, mineral resources like ore deposits, oil and gas, and yes, now geothermal. But I do want a little disclosure as I talk a little bit about me and then go into the talk. I present being a geologist very well, but I need everyone to know that I did not know geology existed until my undergraduate education. And I didn't even know geothermal existed until grad school. But I was exposed to science, I was exposed to earth systems. In fact, there's, right here is the St. Louis Science Museum. I grew up there. If you ever visit St. Louis, just know all their museums are free. If you go to the Science Museum, the first thing you are introduced to is an animatronic T-Rex. It's working, it's robotic, and next to it is a dead Triceratops that's fading out. As soon as you enter this, kids are drawn to it, and right adjacent to it is an earth science exhibit. And so you get funneled through this earth science, kind of meandering your way through this museum. And again, I was just very exposed to it. And then growing up in the Midwest, obviously, all you think about is getting out of the Midwest. So my dad tried to plan as many trips to all the mountains and cool landscapes as we were young. And so I bring this up before I get to my talk because there are folks here that have children, there are folks here that are young, and there are folks here that are still probably figuring out what they're trying to do. And so I know, again, as I talk, you'll be like, oh yeah, she's amazing. She knows what she's talking about. But for the longest time, I did not know what I was talking about, and I did not know what I was doing. And so this kind of linear trend is not really real. It's all very squiggly. And even though my educational background kind of looks very science-y, I actually wanted to be a chef growing up. So for the longest time, I mean, I even worked in restaurants in mid-college. I wanted to open up my own restaurants. I had cookbook collections. I wanted to be on TV. So just know that like anything can happen, and hopefully y'all can get something out of this and maybe be inspired to do something else. But one thing that did stay consistent throughout my entire life was like, just like everyone else, I was a huge nerd. I loved watching Star Trek. I mean, Harry Potter. I was the first on Pottermore. That's like a big brag, right? I did a lot of, I watched all those, sci-fi movies and stuff like that. Even my dad was like, you can only watch PBS Nova documentaries growing up. So that's like a little bit of my background that stayed consistent throughout my life. And so when I pursued science as a career, I found that I had a bigger appreciation for some of the writing, for some of the nerdy things that we have, especially science fiction. And now that I'm pursuing geoscience, it's ended up being one of those, I end up like pointing at the TV and be like, oh my God, they just mentioned geology. What is that? And it's scenes that are like 30 seconds. If you don't pay attention to the dialogue, you probably don't care. But it is actually really integral to the storyline. So for example, in Star Trek, the original, wrong arrow. In Star Trek, the original series, there's an entire episode where they're doing a geologic survey of an uninhabited planet in which Spock doesn't even know what's going on. And so they go on this, they only spend 1 minute of the entire episode talking about how it's gonna be a great paper and presentation for the Interstellar Geophysical Conference. And all I can be is like, that sounds like AGU, which is a huge geophysical organization in America. It's one of the largest geological conferences. We're talking over 60,000 people. They run over 20 peer review papers. And I'm sitting here as I'm pursuing geology, like, oh my God, it's on TV, it's on there, right? It doesn't even go from Star Trek, right? So Annihilation, one of my favorite sci-fi movies. If you have not seen that movie, you need to see it. It's so good. But a big part of that movie, this alien comes in, it's genetically modifying all the species on Earth. But a big part of that movie is how the aliens are modifying the geology of the landscape. And one of the supporting actresses is a geologist, and they just bring it up. It's 30 seconds. It's written in the movie, kind of nuanced and there. But unless you pursue it, you don't really like recognize it. And there you are. That's me right there, as being like, oh my God, it's there. But more specifically, it doesn't go just geology or geomorphology or very overbroad terms, right? I started noticing very, very specific terminology. Some of this terminology was in Voyager. So they visit a planet that looks uninhabited, destroyed by warfare. But one thing that stands out to Captain Janeway and Tuvok is that the electricity is still running. And they're wondering, how is that happening? And then Seven, who used to be a Borg, who found her humanity, points out that the entire planet is run on geothermal. So they're using geothermal systems to run the electricity. The species, well, we learn later that they're not wiped out and they're very hostile. But they are being kept alive in these little incubation tubes via geothermal, and the electricity, 9 decades later, is still on because of geothermal, right? In Homestead, the Talaxians, they're refugees. They end up habiting an asteroid. We know asteroids are very cold. They're desolate. They don't have an atmosphere. What they found is that the inside of a large asteroid is warm enough to melt the ice on the surface and to keep their systems warm. So they are directly using the heat that's inside the asteroid to keep their refugee camp alive. And that's actually, again, this is a 10-second scene, but it's actually really integral to the storyline because they end up, getting kicked off the asteroid again. But they're trying to, the whole point of the geothermal system is that they reuse the conduits to defend themselves, which is really awesome. But it's not just Star Trek, right? I'm very nerdy about Star Trek. Clearly I can point out very specific episodes, but it goes beyond that, right? So it goes to the largest franchise in sci-fi, Jurassic Park. Who knew that Jurassic Park, the island that it's based on, is run on geothermal? Who knew that? 1 person, 2 people. There you go. It's mentioned in all the novels. It's very well described in all the Jurassic Park novels.
But in the movies, if you pay attention really closely, you'll get 10 to 20-second scenes that talk about the geothermal system on the island. And in this particular scene in Lost World, they're trying to, I think, escape thugs, and they need to revamp their communication systems. They have no electricity, but the guy's like, wait a second, there's a geothermal power plant that's meant to run independently of anything else. Let's go visit it, and let's try to figure this out. And it does still work in the movie, and they end up being really successful. And it's not just Jurassic Park, it's The Matrix, right? They don't explicitly state it, but all of Zion, if you revisit the movie, you will find in little tidbits of 10-second interval, whatever, kind of sprinkled in, Zion, in order to stay as a civilization, in order to provide electricity, in order to provide heat for the last humans remaining on Earth, they use geothermal. They describe it specifically, but they don't use it in the script. That's my own beef, though, with the writers. Geothermal in that movie. And it's also used in SimCity, right? So I don't play this video game. I just found it out on Wikipedia. But it's even in our video games. And so you can have it as an add-on. And I guess power your SimCity. I don't play SimCity, so I don't know how that works. But yeah, geothermal is included in some of our popular video games. Okay, so now I have said geothermal about 1,000 times, but have not explained it at all. So geothermal... whether you're in the science and research and development of geothermal or you're in the business of geothermal, all we talk about is heat exchange. How do we take heat, preferably from the earth, and make it something that's usable for us, whether that's generating electricity or heating up our homes or cooling down our homes or developing greenhouses. And so in terms of the higher temperature geothermal, that is heat that's above 100 degrees Celsius or 212 Fahrenheit. The water is boiling, you tend to generate something more energy and electricity. And so what we try to do is harness hot water from wherever exists beneath the earth, generate turbines, generate electricity, re-inject that fluid back down into the earth to be reheated again, and then the cycle continues. It's recycled, and there's no carbon emissions. In terms of direct use, so this is stuff that's below, yeah, go ahead. 100 degrees. We tend to go in the direct use terminology. And what that means is, has anyone been in a cave or a wine cellar? You'll notice, right, year-round, that temperature stays the same, whether it's winter, whether it's summer. It's going to be 50 degrees, 60 degrees, 70 degrees, whatever temperature at that depth. And what we take advantage of is that ambient temperature. Whether you want to heat up a greenhouse at the ambient temperature of 80 degrees, or whether you want to cool down your home to the ambient temperature of 60 degrees. That is what the essential property of direct use geothermal is. And it's all in this umbrella technology term. Now, hopefully by now I've convinced you that this is real, but some people still think it's like warp core technology. I promise you it's not, right? Geothermal is in the science nonfiction. So it exists, it's real, and it's actually in New Mexico, right? So did you guys know that in New Mexico, we have a geothermal power plant in Lordsburg? It doesn't generate a lot. It generates about 15 megawatts, about 15,000 homes. But those are renewable electrons that are direct to the New Mexico consumer. And it's a really great place. I think they do tours. But yeah, we have there's hot water deep beneath the surface. And this company utilizes that hot resource to generate electricity. We also have greenhouses in New Mexico. So for this example, this is Mason Farms. It's in Radium Springs. And they use the thermal resource to keep their greenhouses warm throughout the year. So that means they can grow fruits, vegetables, tropical plants, whatever it is, throughout the year and maintain that temperature without having to use electricity that was generated by fossil fuels. And even more than that, right? We even have companies, they're not in New Mexico yet, but there's a company called Gradient Geothermal. They use geothermal technology to reduce the carbon footprint of oil and gas rigs. So, I mean, you probably don't know this because not everyone here is a geologist, but oil and gas companies, they drill really deep. And they drill deep enough where their hydrocarbons that they're tapping into are hot. And so what happens is for the longest time, these oil and gas companies treated that as waste. They were like, thermal resource, waste. But what geothermal now is coming in is saying, well, hey, we can actually use this thermal resource. We can generate electricity. We can directly use it for our greenhouse, whatever you want. And we can reduce your carbon footprint that way. and hopefully then have a viable solution to having a greener, more cleaner energy future. And on top of that, geothermal is actually pretty affordable. I know here it doesn't look affordable, but I promise to you it is affordable. In terms of levelized cost, so levelized cost means what it takes from start to finish, from people like me to find the resource, to explore it, to develop it, all the way to the end of the lifespan of the power plant per megawatt hour. What is the dollar amount that the consumer has to pay or the company has to pay to keep that? And some folks might see this and be like, well, solar is still cheaper. Wind is kind of still cheaper. So is natural gas. But what I'd like to point out here is this is a function of time. So oftentimes what we don't see is that geothermal runs 24/7. So we don't have to worry about the sun being out for the day, and we don't have to worry about the wind blowing for the day. And so that levelized cost, I just tell people, take it with a grain of salt, because geothermal runs 24/7, 365 days. So by now, I hope that I'm convincing you by now. Usually when I give like this type of spiel to some of the people I meet at bars and I'm like, my hair is rising, they're like, yeah, why not? Let's just do it. Let's just do geothermal. Where can I sign up? But unfortunately, it's not that easy. We can't just go around poking holes in the ground, right? We can't run conduits. We can't just drill down in the ground and just do whatever. We also cannot pop in on the earth. We also can't just fall into a hole or a cave and journey to the center and find heat. It just doesn't work that way. Geothermal is a lot more nuanced than that. It's a lot more complicated. It involves people like us, who are geologists, who actually have to find the resource and find its availability. So a lot of times, geologists, what we do is we try to find where the place is hot, where if there's potentially fluid availability so we can pump it, and if it's permeability. Permeability just is the path of least resistance. So we just want to make sure that when we go into a project and explore, that it's easy to actually access rather than harder. So what makes a really good geothermal spot in terms of a geologist, right? So the most important is heat. And luckily for New Mexico, we have a lot of heat. We're really hot. So like, pat yourselves on the back. You guys are hot without even trying. So typically, heat, in terms of geologic terms, are either from radioactive substances. Don't freak out. It's not like uranium just hanging out. It's natural radioactive decay that naturally happens in the earth that generates heat. It's from volcanoes. It's from plate tectonics. So if you guys rub your hands together, right, you generate heat the same way happens on the earth. And then crustal thinning. So that's actually when you pull the plates apart, like what's happening in Iceland, or what's happening at the San Andreas Fault, where Nevada, this whole state of Nevada is just being pulled apart. The crust is thinning, and heat is able to just kind of swell up into the near the crust. And luckily for New Mexico, we actually have a lot of those resources, as you see on the, I guess, your guys' left. And then what the cool thing about New Mexico is geologists have identified this trend where our hot springs that you guys go soaking for your spa days, or warm water wells that we drill when we have groundwater, are actually along these geologic trends. So there's some validity to this. And also New Mexico has this beautiful Rio Grande Rift, which allows for a lot of heat to come to the surface. There are other things, right, geologists consider, right? Like I mentioned, permeability and water or fluid availability. Now that we've come, if I gave this talk 10 years ago, I'd get more in depth in this. But now that as time has progressed, our technology has progressed, and our capabilities of drilling have progressed. So we can actually engineer around accessibility or introducing a fluid. So, but those are still important, and as geologists, that's what we do, and that's what we try to look for. And then as geologists, what we do is we combine all the factors that contribute to geothermal development, and we create maps like this. This is basically a probability map or an opportunities map. And so what's in red? Red essentially means it's better for generated electrons, and not red, I guess green, is more for direct use. And so part of what we do is then combine this and then approach developers and say, hey, we would like to explore this region more. We have a belief that we can generate more electricity via geothermal if we explore this area a little bit more and do more maps and modeling. It's a little bit more complicated. So I'm actually really good on time. So I want to respect everyone's time, right? I only get 15 to 20 minutes. But as I talk about geothermal, this is just brushing the surface. This is like umbrella. This is bigger than an umbrella, right? This is a whole canopy. So if you are interested in geothermal, I offer you 3 direct resources. The first one is the New Mexico Geothermal Interest Group. That's us. And feel free to scan the QR code. It'll take you to our page. And if you're interested in technical talks, workshops, things like that, feel free to scan the QR code and learn more about the events. You'll likely get an email from me. Especially the science and the development of geothermal, we plan to do more events a little bit more technical than this. We also have a nonprofit dedicated to geothermal. It's called Geothermal Rising, and they serve, oh my God, hundreds of thousands. It's worldwide, it's global, and they have an annual conference every year. But this is a really great, the middle one is a very great page for educational resources. So if you're a teacher or if you're just a general citizen that wants to learn more, great resource page. And their website is done so well. I love the way they do their website. And then the next one is, some of you saw figures, right, of New Mexico, fancy maps, fancy drilling cross sections. If you want to learn more about that resource and learn more about the report, I also put a direct link to a report. It's a scientific report. Proceed with caution. It's very science heavy. But it's very technical and talks about not just the science about geothermal and how it can impact New Mexico, but also the policy changes we might need, the environmental impacts that geothermal might bring to a community, and ways to engage your stakeholders in geothermal. So before I conclude, I just want to get an idea. How many scientists are actually in the room? Yeah, quite a few. Okay, awesome. Right. No, but as a scientist, right, when you watch science fiction, sometimes they get it wrong, right? You watch science fiction and you're like, what are they talking about? That's not right. But the cool thing about geology is what I've learned is science fiction actually gets it pretty right. Like, I'm pretty impressed. So as a scientist, I'm really pleased with, and it's not cringy at all, right? What they get right is geothermal is renewable, it's efficient, it's abundant, it naturally replenishes, it's recyclable, and it's low carbon. Almost no carbon. So it's really cool to see things that are in my day-to-day comfort shows be represented accurately. And that was, I guess, the point of this talk. But yeah, so for those that are wondering, right, New Mexico is in hot water, right? But it's not a bad thing. It's a good thing. All right, happy to take questions. So geothermal is such a broad term. So geothermal encompasses. Oh, sorry. Yes. The question is if geothermal can be implemented in the whole world. And actually, I wonder, because I am a scientist, I have supplemental slides. Nope, they're not there. So yeah, that's not a good one. Geothermal cannot be implemented. It can, but depending on the type of geothermal. So direct use geothermal heating and cooling can be virtually implemented anywhere. Because the point of that is to drill or get to an ambient temperature that you like as the consumer, to then heat and cool your home or generate keep a greenhouse alive, maybe a cement factory. In Nevada, there's a dehydration plant that drilled to a depth at 140 degrees where that's what they want. And they dehydrate onions. That's literally it. So that's how that works. In terms of electricity generation, it's really dependent on the geology. And so what we look for, right, again, is things like are there plate tectonics? Are there volcanoes? Is there crustal thinning? Things that geologists tend to look for. And I highly encourage you to look at a map of plate tectonics and volcanoes around the world, and then active geothermal power plants in the world, and then they just happen to correlate. But yeah. So, that's a loaded one. I think geothermal in terms of land use, in terms of carbon output, and in terms of noise pollution, from what I understand, is very low. And so I encourage you guys, they don't have it here. But in Nevada, there's actually a power plant called Steamboat. and right next to it is a solar field, and the land footprint of the geothermal power plant is like not even a tenth of the size of the solar field, and they both generate similar megawatts, right? So geothermal, the cool thing about geothermal is that, yeah, the land use is very low, actually. There's examples of people still grazing on pasture with geothermal. And noise pollution, I think a lot of people get worried about the turbines making sounds, but we've actually found, Travis actually did the report. What's the decibel amount? It's like 23 decibels for the operation of a plant. So the noise pollution is very low. But yeah, I think the report will also go into more, because and I will say this, with drilling comes risk, right? And that always happens, and seismic risk. And so I'm not going to deny that it's a zero risk energy source. But I also like to invite people to think about the alternatives, right? Right now, our alternative is fossil fuels. And so kind of worry about which ones are, yeah. I hope that answered your question, though. Thank you. Yeah, Lee? Okay, the question is, how as a general citizen, non-scientist voter, how do we help geothermal reach its potential? And I looked at you immediately because I was like, I don't know how to answer that question. That's my boss.
Well, I think educating other people about it is a good first step. We are trying to incentivize geothermal here in the state of New Mexico so we are trying to incentivize geothermal here in New Mexico by providing funding for communities, tribes, and universities to do more research in trying to find the resources. We are also providing tax incentives for installing ground source heat pumps, the heating and cooling of houses. So, letting your legislator know that you're interested would be another good step.
How do industries get involved in geothermal? What industry? Bitcoin mining? Yeah. How do industries like Bitcoin mining and data centers, like that type of stuff, get involved in geothermal?
Well, so right now, what Meta is doing right now, they're wanting to build a data center, and they are engaging a geothermal company to help them do that. Also, you can come talk to us at the New Mexico Bureau of Geology, and we can help you too.
And to add to that, so geothermal, we talked a lot about going beneath the earth, but geothermal technology has been adapted for data centers because they generate a lot of heat. And again, we're in the business of heat exchange. So we have the technology to either help cool or reheat systems as they go. So data centers, so like Meta, Google's also looking into this. How do we make our data centers more energy efficient using geothermal technology, rather than using, local, energy sources that put stress on a local community? Or a huge solar farm, right? The alternative is then adding a huge solar farm right next to it, which takes up a lot of land, right? Acres and acres of land, yeah. Thank you for that question. USA, baby! Oh. Wait, actually, is that true? Okay, I just said that, and I was like, yeah, USA. Well, so USA produces the most megawatts, or I think we're at gigawatts now. 3,500 megawatts. But in a per capita, we're not there. I think Iceland is per capita. Kenya is also second. I think they're per capita. Yeah, so per capita means, for those who don't know, it's like megawatts per citizen, right? So we don't meet our population and our energy demands. We just don't. But other countries do. So Iceland, I think, is like way above half. 80%. Thank you. These are my fact checkers right here. That's why I invited them. Yeah, so Iceland is like 80% geothermal, and per capita, that means when you turn on your lights, and I will say this, there's no discriminating what electron is getting to you. It could be from a natural gas and coal power plant. It could be from a solar field. It could be from a geothermal power plant. There's no way. Once that electron zooms into the wire, you have no idea where it comes from. And so that's kind of what we mean by like per capita is like, if you were to turn on your lights in Iceland, there's an 80% chance that it's coming from a geothermal power plant versus like a natural gas or coal or something like that. Yeah. Lots of learning today. Any more questions? Yeah, so back there. Oh. Do I have to worry about radon as I'm drilling? Is radon ever an issue? Yeah, so I know about other gases like sulfuric acid, H2S, CO2. Like so, especially in volcanic regions, when you're drilling in warm spots, you get a lot of natural outgassing, which is toxic, not just for the humans but for the environment. But do you want to answer that? Because you work for Thermochem, so you actually know.
Yeah, there's a decent bit in volcanic systems that you encounter with geothermal drilling, but current drilling technologies, they're really, really leak-proof, right? It's in the best interest of the driller, both for environmental concerns, but also for personnel on the drill rig to not have any gas emissions. You also want to maintain the pressure in the reservoir to get more energy out of it, so you don't want to have any leakage. So there's environmental regulations, there's economic incentives, and currently nowadays there's abatement technologies too. So in most geothermal power plants, they can abate toxic volcanic gases by 99%. And abatement just means to trap and store that gas in a solid form so it doesn't actually get emitted to the atmosphere or anything like that.
Yeah. Do you reuse the same water? Oh, I can answer. Yes. So yes to your question, but no one else heard that. So she's asking whether we recycle the same water source from the same reservoir, and for the most part, yes. Like we try to tap into one system and one system only, and draw from that and recycle from that system. It's very rare. I think there are geothermal systems that exist, but this is back in the olden times where they just didn't have good geologists. But yeah, we reuse. So that's why it's renewable. So the reason why it's renewable is because we are reusing the same resource. We are not adding or inputting anything. Yeah. Good question. Thank you. Someone else had a question? Lee? Sure. So the question is the fracking risk in geothermal, or just in how do we compare geothermal to fracking? So I'll actually educate. I'll use this as an opportunity for you. So, whoops. That's the answer. So fracking is actually. I feel like I'm gonna. Do you want to answer this?
No, that's okay.
Oh, you're gonna hold that. Yeah.
It's your opportunity.
Oh, thanks. So fracking is an interesting thing because geothermal actually utilizes fracking technology. And I'm going to be very clear and blatant about that. The technology has come a far long way. So earlier in this presentation, I talk about how we engineer around some of these. That one's, yeah. This is actually one of the fracking examples. It's in Utah. It's Forge. They're a very successful project. And what they happen to do is find really hot rock and really hot water, but it's not easy to access. It's like trapped between these rocks. And so what the company is doing is trying to safely, what we call seismic induction or hydraulic fracturing, is kind of simulate mini earthquakes underground to break up the rock and let that resource flow freely. I'm trying to make this the best way, explain it the best way. Huh? Hot, dry rock, yeah. So we do unfractured, yeah. So it's unfractured, and so we utilize fracking technology for that. And so I'm not a driller, so I probably can't answer the question to the best of my ability, but I will say this as someone that's in geothermal, the technology has come a really far way, and the environmental precautions that are put into fracking really, really make sure that they don't contaminate local resources. Because I know that's a big concern with fracking, right, is that you contaminate. I do also want to point out geothermal drills well below drinking water. We are going 2, 3, 4 kilometers. I'm trying to do math conversion in my head of what that means in miles. But we're well below what most drinking water or what you're using for your residential, what you're using for farming or anything like that. So oftentimes the geothermal resource is well below that, and we have things like casing and things to protect it from that. So yeah, and they're like, so geothermal, this all sounds new, but it's not new. It's been existing for years. There's never been, so Travis just mentioned, there's no like environmental or legal case in the US where geothermal fracking has environmentally impacted the community around it. Yeah. Yeah. Thank you for that question. I'm sweating. Any other questions, or do we have to move on? Oh, there's another question. Yeah. Yeah. I can't hear you. I'm so sorry. Can someone just yell, like whisper in her? We'll do telephone and then. No. Oh yeah. Okay. Oh, okay. Yes. So her question is a really good one, and it's whether geothermal exploration and drilling along the Rio Grande Rift, like along the rift, will cause more seismicity or more geologic hazards, so like earthquakes. So I do want to introduce the idea of scale. So in terms of geothermal drilling, or just any drilling in general, we do not drill at the scale that will interrupt any earth processes. So yeah, it might maybe locally, you might see a drill rig or something, but to put it simply, an asteroid has to hit the Earth in order for like things to actually seismically change. Like the scale in which we operate is very small compared to the extent of the Rio Grande Rift, right? So we're talking about a massive Earth body that's tectonically bound in the country, and then the geothermal well is like, think of like almost literally a needle in a haystack, right? In terms of like the scale and the scope of the Earth. I hope I put that properly. I don't know how else to, yeah. But I hope that answered your question. Yeah. So you can, so there are technologies, so we call them thermal energy networks. And we also and it's more on the direct use and ground source heat pump realm, where you can actually, there's even a community in Colorado as we speak that's near a hot spring that wants to utilize geothermal for its community, for direct use, for heating and cooling. And the whole community is coming together, the small mountain town, to drill and then develop an interlocking system. But if you have your phone, I would encourage you to look up thermal energy networks. And that's literally what you're describing. So her question was about, is it economically viable for neighborhoods? Oh, go ahead.
And New York and Massachusetts.
Oh, New York and Massachusetts, too. There's a nonprofit called HEAT, H-E-E-T. And they specialize in what they call thermal energy networks. So it's revitalizing the energy systems of neighborhoods. And it's really successful in New York and in these city places. What they do is they repurpose gas lines and plumbing systems to do direct use geothermal. And so residents can now heat and cool their homes very efficiently. But yeah, sorry, I know we have a speaker. But I do want to end on this. We do have a whole table here. We're happy to answer your questions if you have any more. But thank you guys so much. That was great questions. Oh my God, yeah.
Thank you so much, Dr. Pooja.